with the first switch, and then I added a second switch, and I connecting both switch in parallel. This cable is connecting both of the switch, and then this cable is connecting it to the LED. The long leg of the LED and the short leg is connected to ground. And then when we press both of the switches, it turns on. If we press only one, it doesn't turn on. We have to press both of them. I have connected each of these switch, each one to the resistance. This side is connected to this resistance, and then this side is connected to this leg, and then the same for this switch. So they both have like a complete circuit. So now when I press one, the LED turns on. When I press the other one, the LED turns on too. Phase shift interface for this one, I had to connect 3 LEDs, 2 red ones and 1 green, and also a switch. Each LED is connected by 1 resistance to ground, and also the switch. And then the LEDs, they are connected by a wire to the Arduino digital pins. The green ones is to digital pin number 3, and the other 2 red ones are to digital pin 4 and 5, and the switch is digital pin number 2. The switch is on the program. I had to name it as an input, and the LEDs are the outputs. And then on the code, I also had to put the switch state, which is how is the switch, like when it's pressed, it's supposed to be low. I mean, when it's not pressed, it's supposed to be low, and when it's pressed, it's high. So when it's not pressed, the green LED is high, which is like turn on, and when the switch is pressed, it's low, and the red LEDs are high. So we have a delay time of 250, but we can also change the delay time to 100, and it will go faster. The red lights will go faster. Here, the delay. So here we have the green light again, and when we press the button, they are faster. This is the Lovometer project. Here we have a temperature sensor. The first leg is connected to voltage, the other leg is connected to ground, and the leg on the center is connected to the analog pin on the Arduino. We also have three LEDs, and each of them is connected to a resistor to ground, and the anode is connected to a digital pin on the Arduino. Here is the code, and we're gonna get a sensor value. We are also gonna have a voltage, and we are also gonna have the temperature, which is gonna be on Celsius. So when the temperature changes on the room, it's supposed to, if it's 2 to 4 degrees over the baseline temperature, which is 26 degrees, this LED is gonna turn on. If it is 4 to 6 degrees over the baseline temperature, this LED is going to turn on, and if it's more than 6 degrees over the baseline temperature, this LED is going to turn on. So we're going to start the simulation, and here we get the values of the serial monitor. And then when we put the temperature higher, here is in 25 degrees, so if we put the temperature higher, we can have the first LED turn on, and then the second LED. And then if it's 30 degrees, which is 6 degrees over the baseline temperature, the 3 of the LEDs are gonna turn on. Class project, we have 6 LEDs on the board, on the breadboard, and each of them is connected to ground by a 220 resistance to ground, and the other leg is connected to a digital pin on the Arduino. And also the tilted switch, which is this one, is connected to ground, and also to a digital pin number 8 on the Arduino. And the breadboard is connected to voltage into ground. And now that I have the code on my computer, I already tested, and I also changed the long interval from 60,000 to 1,000. And this is because I want it to be 1 second of delay. And now we're gonna upload it, and it's gonna start. And that's it. So for this project, I used only the servo motor and the Arduino. We didn't use the breadboard this time. We only have to connect the Arduino to the servo motor by connecting it to voltage, and then, which is the red wire, and then the orange wire is 0.9, and then ground is the black wire. And then it's also connected to USB to the computer, and I uploaded a code which came with the Arduino, and it's called servo. And what this code is gonna make is that it will move the servo motor to 90 degrees, and then to 60 degrees, and then again to 90 degrees. And then I put delay time between these moves of 500, which is half a second, and then on the other one 1,000 seconds, so it will take 1 second to the loop to repeat. So now I'm gonna connect the Arduino to the computer, and it's already moving. It moves 90 degrees, 60 degrees, and then 90 degrees, and then starts again. I use an LCD screen and the ultrasonic sensor, and I connected them both to the Arduino. They are all connected to digital pins and to ground and power, which is 3.3 volts. And then it's connected to the code on the computer, and here is the code. I got it from the internet. And the LCD is a liquid crystal, it uses a liquid crystal library, which is already uploaded to the code. And then here in the screen we can see the distance. It's trying to figure out which distance to measure. But if I put my hand here, which is in front of the ultrasonic sensor, it starts measuring how far my hand is. And you can see 3 centimeters, 10 centimeters. I don't have a ruler with me, but we can see like this is 3 centimeters. And then if we go this way, we can see 18, 20, 22, 25, and it's getting up. My hand is already over here. So you can see like my hand is over there, and it's still measuring. Use a ultrasonic sensor and a servo motor, and the ultrasonic sensor will make the servo motor move. These two terminals, echo and trig, are connected to the Arduino to digital pins number 2 and 4. And also from these, the servo motor is connected to digital pin number 9, and it's also connected to power into ground on the breadboard. And here's the code. I got it from the internet. And then when we get close to the ultra sensor, it makes the servo motor move. So we can see that it only moves from one side to the other side. It doesn't make a complete circle. So for this project, I used the LCD display a thermistor and a potentiometer. So this is the LCD screen, and here's the thermistor here, and here's the potentiometer. So what this project does is that it measures the temperature in the thermistor. So if I put my finger here, it starts measuring the temperature. It starts going up because it's getting hotter. And also the potentiometer is for the LCD display to adjust the brightness. So if I go down, you cannot see anything. But if I go up, you can start seeing the temperature. So the LCD screen is connected to the Arduino, and also the thermistor is connected to one analog pin, and the LCD screen is connected to the digital pins, and the thermistor is connected to voltage, and to ground, and to the LCD screen. And then here is the code. I got it from the internet, and it only needed one library, which was already uploaded to the Arduino, and it's a liquid crystal. And here we can see the code. And it also needed a 10K resistor, which is there, and it's connecting the thermistor to ground. So yeah, so this is a project.